Good morning, students. Last class in the metallurgy, we discussed about in the last class in the metallurgy chapter, we discussed about what? The concentration of the ores. Okay, so in that we discussed hydraulic washing and also a magnetic separation. Okay, so in that we discussed hydraulic washing and magnetic separation. These two already discussed in the last class. Okay, so listen. Hydraulic washing means it is the ore is washed by the stream water. So in that the ore particles that are collected are denser compared to dense gravity or more gravity compared to the gangue particles. That's why ore particles are settled down and the gangue particles are carried by the water stream. Okay, so that is the principle. Next, principle means actually the separation techniques in the hydraulic washing is done by the difference in the gravities of the gangue and the ore particle. Okay, so but in magnetic separation what happens? Based on the difference between the magnetic properties, that is whether they are attracted by the magnetic field or they are repelled by the magnetic field. So yesterday's class I taken an example iron. You know, iron is a ferromagnetic substance, that means it is strongly attracted by the magnetic field. While this is strongly attracted by the magnetic field means, of course, it is collected nearer to the magnetic roller, in which the powdered ore is carried by the conveyor belt around the magnetic rollers. Okay, and the gangue particles compared to ore particles, they are less affected by the magnetic field and they are fall somewhat away from the magnetic roller. So by that principle, we can easily separate a gangue particles from a ore particles. That is magnetic separation. Okay, so third one is froth flotation. Froth flotation. What is froth means? It is a type of a bubble formed during the washing powder. When we mixed with water, we will obtain some type of foam. Foam means norite. Okay, so that is what froth flotation. Okay, so that froth, by the formation of the froth with the particles of ore and the gangue, we are going to separate the gangue particles from the ore particles. So further arrangement is given here. Write the arrangement first. So this is a froth flotation chamber. Okay. So to this, a rotating paddle is connected. A rotating paddle is connected. Here, there is a space to the entry of the air. Here, water is present. This is all water. Okay, until here. Okay, so next, this is the froth. Froth means, I told you, a type of bubbles formed while we mix water with the washing powder. This is what? Froth. Okay, students, this is the arrangement. Okay, so here this is rotating paddle. This is This is completely a froth flotation chamber. Okay, so here what happens? The technique or the principle involved here is, I'll write the principle first. The principle involved in this froth flotation is the separation technique. The separation technique is done based on the wettability. Wettability means, as I said, drop of the gangue and or particle. Okay, the separation technique is done based on the wettability of the gangue and or particles, or based on difference in wettability. You have difference in wettability of the gangue and or particle. So what is meant by wettability, student? So listen, here I told you the chamber is there. In that chamber here water is there. Here froth is there. How the water is settled here, how this froth will form is, listen, this type of technique is specially used to separate the gangue particles from the ore consists of sulfide ore, that is sulfide ore specially. It may be ZRS, PBS, FES, U2S, etc. The sulfide ores are separated by using froth flotation method. Okay. So listen, here what happens? First, this powdered ore is, or the suspension of a powdered ore is taken. The suspension means, so this is the suspension of a powdered ore which is mixed with water. Okay, ore is mixed with water. To this ore, so listen, fine oil or fatty acid or xanthates are added. Fine oil or fatty acid or xanthates are added. So these are collectors. These are called as collectors. Fine oil, fatty acid or a xanthate. So along with the fine oils, again cresol or aniline is added. These are froth stabilizers. These are froth stabilizers. Okay, and right here you will not see clearly. Cresol and aniline. These are froth stabilizers. Okay, students. So listen, what is this collector's function? What is this froth stabilizer's function is? So listen, the powdered ore made it into a suspension. That suspension consists of the powdered ore mixed with water. Along with water, these collectors and the froth stabilizers is added. Okay. So what is the role of this fine oil, fatty acid, xanthates, and aniline and cresol is? So these are called as what? Collectors. So here the principle is based on the difference in the wettability of the ore and the gangue particle. Means here water is there, these collectors are there. So which particle is wetted, means attracted by the which one? Okay. So here gangue and ore particles are there. So these collectors collect or wet ore particles. Okay. And this water That water is wetted the gangue particles. So gangue particles are wetted by water and the ore particles are wetted by fine oil. Okay. So but these oil, oil and fatty acids acids are there. So compared to oil and water means though both are form a heterogeneous mixture. Heterogeneous mixture means there is a clear separation layer between the two layers, oil layer and the water layer. So in that, so oil are compared to water, oil has less density. So oil floats above the what? Water. Okay. At the same time, when the ore particles is connected by these fine oil fatty acids or xanthates, any collectors, then this cresol and aniline, okay, stabilizes the froth. Okay. Why? When they stabilize the froth, listen, here rotating paddle is there. Okay, so that rotating paddle is rotated like this. Okay, so listen, if in a cup of bowl, cup of water or in a bowl, glass bowl, if we pump some water means we'll observe some amount of bubbles. Okay, if we blow the by using straw or anything else, if we blow air inside the water means some bubbles will appear. So that is only happening here. So here water is there, including these collectors and stabilizers. So at this time what happens? When the air blows into this, the rotating paddle rotates. When the rotating paddle rotates, the bubbles are formed. So that bubbles carries this collectors. Okay, and forms froth. There is a much froth production, that's why this aniline and cresol stabilizes the froth that only a ore particle can collected by these collectors. Okay, that is the function of the froth stabilizers. This is the 1 marks question. What are the collectors used in the froth flotation process, or what are the froth stabilizers used in froth flotation process? Okay, so this is the thing. Once the collectors which are these fine oil fatty acid or xanthates are ore particles wetted by these collectors converted into a froth. The froth is taken in a separate and it is subjected to dry. Okay, when it is subjected to dry, so then water molecules are a finite. It can be easily removed, okay, by washing or anything else by different using methods. So you will get a pure ore. So listen students, I told you here most preferably this technique is suitable for a sulfide ores. So this can be used to separate a ore consists of two different sulfides. For example, ZnS is also there, PBS also there. In one single ore, both ZnS is there, PBS is there. So to this, we can separate these two by adding a concentration of by maintaining the suitable concentration of the collectors or by adding depressants. Okay. So depressants means, listen, for these two, NaCN is the depressant. NaCN is the depressant. So then what happens? This NaCN stabilizes PBS, or it controls the PBS to react with the collectors or to form froth by the collectors than ZnS. So here what happens? PBS remains in the solution as a suspension, only ZnS is formed as a froth and it is taken out and then it is separated. Again then it is subjected to the PBS process. Okay, by maintaining the concentration of the collectors or by adding any depressants. Depressants means which suppress the froth flotation, formation of the froth of the any one of the pore. Okay, so this is the example. This is under the froth flotation process. Okay, so I told you in the froth flotation, the principle is the separation technique is done based on the difference in wettability of the gangue and the ore particle. This is what are collector? This is important for 1 mark. What is froth stabilizer? Which are froth stabilizers and what is their function? That is important for 1 marks. And also to which type of ore? Or the sulfide ore is basically concentrated from which type of a concentration process? Means that is froth flotation. These are the 1 marks questions they may ask in the examination. Okay. At the same time, for 2 marks, they will ask principle as well as explanation. Okay, student. So this is the third concentration process or a concentration of O. So next one is leaching process. That is leaching process. Listen, these two are physically or physical process which can be done physically by using physical properties, and we may separate them without adding any extra chemicals. Okay, these three are physical separation methods, and this one is chemical separation methods. These three are important for 2 marks. This one is important for 3 marks. Okay, so listen students, I need much space, so I'll drop this. The fourth one is the leaching. Okay. So listen, for that example is leaching of aluminium from bauxite ore. Leaching of aluminium from bauxite, that is Al2O3. Okay, so this process has 3 steps. In step 1, what happens I will say? Step 2 is there and step 3 is there. So in the first step, listen, the bauxite ore, okay, is mixed with, okay, suitable material. So listen, here this leaching process takes place based on the solubility of the metal atoms with any other atom. So here listen, this leaching, that is aluminium bauxite, is mixed with concentrated solution of NaOH at 473 to 523 Kelvin temperature and 35 to 37 bar pressure. So then bauxite is precipitated as sodium aluminate. Bauxite is precipitated as sodium aluminate, students. Okay, so listen, here bauxite is mixed with concentrated solution of NaOH at 473 to 523 Kelvin and 35 to 37 bar pressure. So here then bauxite is precipitated as sodium aluminate. Okay, so here the reaction, bauxite means Al2O3, okay, this is solid, mixed with concentrated solution of NaOH, okay, concentrated solution of NaOH, okay, and H2O. Then what happens? This sodium is dissociates or precipitated as what? Sodium aluminate. So aluminate means Al OH 4 times ion. Sodium aluminate means Na2. Okay. Next. Plus 4OH minus. So this is the not this is Na2 Why? Because aluminium it is a complex. So this is in +3 oxidation state. Here -4 charge is there. -4 plus 3 means -1 charge there. That's why only one sodium is taken here. Sodium aluminate. This is sodium aluminate. It is a precipitate. Okay. So then what happens in the second step? Sodium aluminate is neutralized by passing CO2 gas. Okay, the sodium aluminate is neutralized by passing CO2 gas and forms hydrated aluminium oxide, that is bauxite again. Okay, I'll write the equation. Sodium aluminate is neutralized by what? AlOH 4 times plus CO2. Okay, so this is the equation. So this is a gas, this is solid. So here what happens? What I said? It forms hydrated aluminium oxide. That means Al2O3 into XH2O plus NaHCO3 plus NaHCO3. Okay. Next one is the hydrated bauxite or aluminium oxide. Al2O3 I said means oxide is heated up to 1473 Kelvin. 1473 Kelvin. So then what happens? This Al2O3 into XH2O is heated at 1473 Kelvin. Then water molecule separates out, that is Al2O3 plus XH2. So this is pure aluminium oxide. Okay. So listen student, here I didn't write condition right here. 473 to 523 Kelvin, 35 to 37 bar pressure. You have to write the condition also there. So this is the leaching of aluminium from bauxite ore. So 3 steps are involved. These 3 steps are important for 3 marks in the examination. So what you have to do is, if the as, and this is the compulsory in the expected question in the examination, so you must and should read and write this often and be thorough in this concept. Okay, leaching of aluminium from the bauxite. So here step 1 is bauxite is mixed with concentrated solution of NaOH at 473 to 523 Kelvin and 7 bar pressure. Then the bauxite is precipitated as sodium aluminate. So here Al2O3 is there, bauxite reacts with concentrated NaOH in H2O in presence of that aqueous solution means H2O is present, then it forms sodium aluminate. Once the sodium aluminate forms, then it is neutralized by passing CO2 gas, forms hydrated aluminium oxide. Hydrated aluminium oxide is heated up to 1473 Kelvin, then we will get pure bauxite, that is Al2O3. Okay, so this is leaching of aluminium from bauxite. Okay, we clearly take down this notes and practice as early as possible. This is the compulsory and expected question. Okay, next. Another one is same thing. Leaching of gold and aluminium. Gold and silver means precious metals. Okay, first leaching you learn. In that listen, the metals are first. First I write the equation. So listen, metals reacts with KCl or NaCl in presence of air and also diluted solution. Okay, this is liquid, this is gas, liquid that is aqueous, this is solid. Okay, so then what happens? They are formed MCl twice compounds. This is 4 moles, this is 8 moles, this is 4 MCl2 complexes, that is metal cyanides or cyano-metal compound. So listen students, plus 4OH minus. So here what happens? This metal cyanide formed. This metal cyanide formed is treated with any other metal. Is treated with any other metal that is more reactive than these metals. Okay, this selection of metal is based on the Elingar diagram which reduces the other metal. Okay, that way I will explain you in a later class, because in applications of Elingar diagram you will study this, which metal is suitable to reduce other metal. Okay, so here what happens? It forms Zn Cl 4 times plus 2m. Okay, so this is the first what happens? Metal, step 1, metals are mixed with aqueous solution of NaCl or KCl. Instead of mixed with, they heated with solution or in presence of air. Okay, next step 2. The metal cyanides are treated with suitable metal atom. Okay, then you will get this. So listen, this type of methods is used to extract the metals that is called as precious metals. The precious metals are gold, silver, platinum. Gold, silver. If M may be gold, then what happens? This M is replaced by what? AU. So listen, I'll change here only. Metals is there, metals are heated. So in the place of metal you take gold. Okay, if you take on gold or heated with aqueous solution of NaCN or KCl in presence of air means this M is replaced by what? AU. Wherever N is there, you replace that by AU, you will get answer. Okay, so instead of AU, you can take silver here, then that is Ag. Instead of Ag, you can take platinum here, that become PT. Okay, so students, for you, what is the homework means? I wrote, this is the standard equation, I'll write it again. Okay, in all the case, M only there. Here, metal is there. So for you students, you replace this step 1, step 2, M by AU, Ag and PT. Silver, gold and platinum. Okay, write again the 3 equations. Okay, so write it again and send a screenshot in the group. Okay, send a pic in the group. This is the homework for you students. Okay, it is compulsory. By evening, I want all to answer for this questions. Okay, so listen. Leaching is the chemical process of extraction or removal of gangue particles from the ore particles. In that I explained already the leaching of aluminium from bauxite. This is another one, leaching of metals from respective ore. Only the precious metals. In the precious metal, gold is there, silver is there, platinum is there. This is the general steps. First, what happens? The metal, respective metal, is heated in presence of NaCN, KCN, the aqueous solution. In presence of air, then you will get metal cyanides. That metal cyanides again treated or reduced or reacts with respect to metal, which can be the ability to reduce this metal and forms a two metal. So whatever the metal we want, that we will get from that. All the impurities are removed in this only. So here, this is the chemical process. Only the respective elements reacts means rather than the 3 before what we discussed, the magnetic separation, hydraulic washing and the flow flotation. This is the best method to purify the concentration, to purify the ores, because small particles also removed from this process. Okay, so this is all about leaching. So your homework again I will repeat. Replace this M by AU, Ag, platinum. Write the 3 equations for different metals and send it to me in the group. Okay. So this is all about the concentration of the first process of metallurgy, that is concentration of ore. First 3 methods are important for 2 marks. This is very important for 3 marks, and this must be the expected portion. Okay. Next is, once the concentration process done means, I told you, next one is isolation of metal. Isolation of metal from the concentrated ore. You write here from the, here we are using concentrated ore because in the first step we did concentration of the ore. Okay, so isolation of metal from the concentrated ore. So here first one is ore is conversion to oxide. The ore is converted to what? Oxides. Okay. Next. Second one is reduction to metal or reduced to metal. Converted to oxide and reduced to metal. So in this conversion of oxide to metal is there, that is calcination and roasting. Calcination and roasting. So what is calcination means? Listen. Heating of a concentrated ore in the absence or limited supply of air. Okay, heating of a concentrated ore in the absence or a limited supply of air, that is called as what? Calcination. What is roasting means? Heating of a concentrated ore in the sufficient supply of air, or you can also say presence of air. Okay, this is absence of air or limited supply of air, that is heating in sufficient supply of air. Okay, student. So in this sufficient or also you may write regular supply of air. Regular supply of air. So here in this calcination, oxides ore are preferred to be converted into oxides. Here only oxides ore are preferred to convert into oxides. Here sulfides. Here sulfide ores are preferred to be roasting, converted from sulfide ore to what? Oxide ore. So in that, students, listen. First one, Fe2O3 into XH2 is there. So heated in the limited supply of air or in the absence of air, we will get Fe2O3 into plus XH2O. Here what happens? Hydrate molecule is there, hydrated. So water molecule is present as an extra impurity here. So to remove it, this is hydrated, sir. So it is converted into what? Oxide. So hydrated is converted to oxide. Okay. Next, zinc carbonate is there. When it is heated means this changes to ZnO plus CO2. Carbonate ore is there. So by heating, it forms zinc oxide and also CO2. Okay. At the same time, combinations of ores are there, CaCO3 and MgCO3. When they are strongly heated, again they form CaO plus MgO plus 2CO2. Okay, students. So this is the example for roast calcination. Okay, the hydrated salts and the carbonate salts are it undergoes calcination because they are already consist of a oxygen molecule. Here we don't require much oxygen to convert into oxide. Okay, here already they consist of the oxygen atom. So that's why in the absence of limited supply of air, what happens? They converted into, if hydrates converted into oxides, carbonates converted into oxides, again the carbonate converted into oxides. I told you most preferably the oxides, sulfides and carbonates consist of present in the form of a O. Okay, so O mainly consists of oxide, sulfide and carbonate. So here what happens? Eating of a concentrated O in the sufficient regular cycle. So here you take ZNS. Okay, we require what? Oxygen molecule. So it formed into ZNO plus SO2. Take this is 2 times, 2 times, 2 times, 2 balance. Okay, so another one is there PBS plus O2. This is 2 into PBS changes to here 2 PPO plus 2 SO2. Okay, next Cu2S is there, again 3O2 is there, this is 2 times, or you may, okay, then you will get 2 Cu2O plus 2 SO2. So only the sulfide ores are preferred subject to roasting because in presence of oxygen, because the process is conversion of concentrated ore to oxides. In the calcination is there, roasting is there. Here in presence of air we require, because these are all sulfide ore means there is no oxygen. To convert it into oxygen, we require oxygen molecule. So in the air, the oxygen is also present. So these foods, when they are strongly heated in presence of air, they use oxygen molecule. Okay, you know, in presence of air, the burning, means heating process takes place very strongly. That's why this is called as roasting, completely fried like that. Okay, so this is the Denbo PP1 CO2. This is calcination and roasting. Okay, so next one is reduction to metal. Okay, this is conversion to oxide. This is complete. Next one is reduction to metal. So here in this conversion to oxides, we did all the ores are converted to oxide ores. Then this is reduced by using carbon or a suitable metal. Carbon or a suitable metal. Okay, carbon or a coke is the best example. So listen, here MX Y type compound is there. Reduction I am telling. So Y amount of carbon we require, carbon or coke. So then what happens? It forms X moles of M plus 5CO. This is the general equation. So listen, Fe2O3 is there. We don't know how much carbon we require. Fe will separate out along its speed. Here in the X position 2 is there, Y position 3 is there. We require 3 carbon, 3 moles of carbon. So here X moles means 2 Fe, that is 3 C. Okay, next another one Fe3O4 is there. So to this we require 4 carbon, then it forms 3 Fe plus 4 CO. So this is the equation. So by using the carbon, we will convert this oxide ore into a respective metal. So this is what isolation of metal from the concentrated ore. Once this metal is isolated, then it is subjected to refining methods. Okay, this is the second process. Second process is somewhat easy to learn to you people. Okay, listen students. Another, I told you another metal can also be used. Listen, here I told If Fe2O3 is there, to that if we use zinc, okay, there may be a chance of formation of Zn plus BPFE. This is 3ZNO, 3ZNO to Fe. Okay, by reacting with another metal, by treating with another metal which has the capacity to replace this metal also, we can reduce the metal. So this is reduction to metal or reduce the oxide coal to metal. So this is isolation of metal from the concentrated coal. In the next class, we will discuss the thermodynamic concepts, that is how the delta G and delta S varies these concepts, and at the same time what is the refining techniques used in this. Okay, thank you.